The Bioceuticals Integrative Medicine Awards are fast approaching. The Beamers showcase the outstanding talent we have in the Australasian integrative medicine profession and are held in conjunction with the Bioceuticals Research Symposium. To book your ticket to this gala dinner event, visit bioceuticals.com.au and click on the Education tab. This is FX Medicine. I'm Andrew Whitfield-Cook. Joining us on the line again today, after a long sabbatical, is Vanita Dahia. She's an integrated medicine clinical consultant pharmacist, naturopath and clinical nutritionist with over 3 decades of experience in compounding pharmacy, functional pathology, herbal, Ayurvedic and integrative medicine. Vanita is board certified in anti-aging and regenerative medicine with the American Academy of Anti-Aging Medicine and a member of the Professional Compounding Centres of America and Australia. Vanita is an international speaker and author of Alchemy of the Mind. Welcome back to FX Medicine, Vanita. How are you?
Thank you, Andrew. Good to hear from you again.
Now, today we're going to be discussing a rather devastating disease, motor neurone disease, and talking about hopefully some of the nutritional support that we can give these patients. But I think first, can you take us through a brief description of MND and the different types and also some of the proposed causes?
Sure. Look, MND has gained a lot of repute lately as a result of the passing of Stephen Hawking.
Yeah.
And he was an amazing physicist, and it just shows that MND did not affect his brain. So what in actual fact MND is, it's a baffling disease. It's multifactorial, it's genetic, it has a lot of environmental causes as well, and it's really a progressive degeneration of the corticospinal tract as well as the anterior horn through the spinal column, and it affects the bulb and motor nuclei. So these motor neurons are the ones that are basically affected. We've got 2 sorts of neurons. The motor neurons, these are the efferent ones. They take information from the central nervous system to the periphery. And then there's the sensory neurons. These are what we call the afferent neurons. They actually take information from the periphery into the central nervous system. So what actually happens, I guess in MND, the cells in the sensory and the peripheral neurons just start dying. And the lysosome inside the cells, they give up the enzymes, they just start to die. Then you get the cellular apoptosis. In other words, the cells start to commit suicide in a way. So, there's quite a few. You asked about the various types of MND. And lately there seems to be a lot, as I was researching on this topic, I realized that there's a lot of versions of MND where it affects either the upper or the lower motor neurons. So the upper motor neurons, they actually originate at the frontal lobe. They go to the brainstem and the spinal cord, whereas the lower motor neurons, they have their cell bodies in the spinal cord, so they go to the peripheral neurons. So this is why you will see somebody like Stephen Hawking. He had some control, but he didn't lose his sensory control. In other words, he could hear, he could have all voluntary muscles working.
He could have sensed, though, correct? There was no problem with sensation in the limbs that were affected?
So he could actually have, there's actually numbing. What happens with MND is immobility in the periphery. It could affect one foot. Then it affects the next foot before it hits the next organ.
Right.
Or it affects one arm to the next arm. But they can control sexual organs, for example. They can control sphincter muscle control initially. Later down the line, it starts to disintegrate.
Right.
Because it's a progressive neurological disorder. So it destroys motor neurons, the cells that control the voluntary muscle. So then they lose their ability to speak, and they lose their ability to walk or breathe, and swallowing. Swallowing is a very big one. Because what actually happens, they start to swallow their saliva and their food, and it enters into the trachea, leading to a major respiratory distresses. And that's probably where a lot of the degradation happens in MND.
So, causation. So I thought it was purely genetic, but there are some other causes?
Yes. Look, about 10% of all MND is inherited. So there's a genetic disposition there. Autosomal dominant, essentially 90% of it is not genetic. So there's two streams of research that is being done in MND and its associated conditions. Just in regard to the associated conditions, one that we're probably very familiar with is ALS, or amyotrophic lateral sclerosis.
Yep.
You've probably heard of that. It's also known as a Lou Gehrig disease. Lou Gehrig was one of the first person that was actually diagnosed with ALS. And so it affects all these various conditions, affect different parts of the motor neurons. So I guess I should answer your first question first, which was the types of motor neurone disease, because that will give us an indication what can possibly cause that. Mm. So the types of motor neuron disease are ones that really, like ALS, affects both upper motor neuron disease. And then you get the other versions like PLS, which is primary lateral sclerosis, and that only affects the upper motor neurons. And then the ones, there's another condition which is called progressive muscular atrophy, and that affects the lower motor neurons. So there's various versions of it, and there's some that only affects children, like SMA is a form of neurological defect that prevents babies from, it affects babies predominantly, it affects children from birth because they're unable to sit, and they often die before the age of 2. And then there's now, when you're asking about causes, there's a couple of areas of causes. There's a condition called neurolatherism, which is a permanent paralytic condition, and it tends to be occurring in the famine-affected areas, and it's caused by this unusual amino acid called ODAP, O-D-A-P, which stands for oxalate diaminopropionic acid. That's one. So if we look at the underlying, fingers to point, if we look at the deadly dance of nerve destruction, where is that biological spark coming from? Some of the sparks are coming from the underlying cause of perhaps exposure. So exposure to blue-green algae. This has been studied quite extensively by Rachel Dunlop at the University of Sydney. Yeah. And what they've found that these blue-green algae, they're huge plumes that stretch right across the Murray between Albury and west of Swan Hill in Victoria in Australia, but also up north they found it in New South Wales, up the Murray and the Murrumbidgee River. Along there, they found that these blue-green algae, what they do is they contaminate food. They move into the food chain, and they do this by mimicking an amino acid. They mimic L-serine, which is an amino acid that prevents the amino acids from actually folding and functioning properly. So that then leads to that toxicity. So they found that this particular toxin is called BMAA, which stands for beta-methylaminoalanine, another amino acid. This is a toxin that they found not only as a result of exposure to these blue-green algae, and they bioconcentrate in these cells, but also they found that this particular toxin was also found in a unwashed cycad seeds. Cycad is actually a seed found in Guam and Papua New Guinea, and they actually found these seeds in Japan as well. And what they do, these ethnic groups, including Aboriginals here in Australia, they found that the chamois tribes use these seeds, these cycad palm, it's a palm seed, and they used to make tortillas and dumplings out of it. But they were very smart. The Aborigines knew that they needed to wash the flour of all the poison before they could use that. Now, those that didn't wash that were accumulating BMAA, which is your beta-methylaminoalanine, and they were exorbitantly high in patients with MND. So it is bioconcentration of that underlying toxicity. And you know what? They also found that in bats. There's these chamois tribes. They ate bats. And they found in this area of Guam and Papua New Guinea, these bats were consuming or had high levels of BMAA. And they found that that was contributing towards the toxicity as well. So it's quite interesting, isn't it?
Yeah. Can I just ask you, with regards to bats, there's this worldwide issue of bats being knocked out by fungus. I'm wondering if that might have any play to part in the increasing incidence of this amino acid found in the bats. And I'm wondering, therefore, if it might be something along the lines of an aflatoxin that we'd see in nuts from fungal production.
As a result of, I guess I can't answer your question effectively because I don't know. However, as a result of these blue-green algae in these various plumes, as well as the fact that these cycad seeds are found in tropical dense forests, palm trees, there is a high propensity of accumulation of ochratoxins, aflatoxins, leading to conditions that we now know and well recognize as neurodegenerative conditions.
Okay.
And that is your mold biotoxins, your Lyme disease, and they all presenting with really significant autoimmune pictures, such as we call them chronic fatigue syndrome, we call them Lyme borreliosis. So there may be an opportunity for us to investigate that further.
This is the sort of thing that interests me, is that we, as humans, we like to target something and say that was the cause. But then if you delve further and you look back and back and back, there might be some other factor causing that thing to happen in that vector, organism, whatever, and we attribute the vector, whereas the real culprit was something far more distant.
That's true, yep.
That blue-green algae, though, that's really interesting.
It is, and it's been very well researched lately as a result of, as you probably well know, in Australia we have the Ice Bucket Challenge, and so there's a fair amount of research which is fortunately being funded and operated right here in Australia, particularly in the genetics area as well. And I know that it only affects 10% of MND, but there's some really interesting genes that have been identified and associated. So there's a race to find the genetic construct associated with MND.
Wow. So it's such an important area and of a devastating disease. What about the symptoms, though? Is it always insidious? Like, I remember in the movie of Stephen Hawking.
Theory of Everything?
That's it, The Theory of Everything. I remember, it started off with a little bit of clumsiness. And that's often what people present as. They tend to knock, a hip on the desk all the time. And it's like, oh, that's strange. And then suddenly there seems to be this quite a significant drop in functioning of the muscles. Does it always start with just this weird insidiousness and then, bang, there's this steep progression in the disease?
That's correct. You will find that it's a slow onset. And what it does, it affects the signals to the cortex just don't work. It's broken.
Yeah.
So the nerves get attacked. So the first thing you will see is some form of palsy. So it's usually a bulbar palsy where you see some level of paralysis. And it usually might affect just a foot initially, and then it'll affect the next foot, and then it'll start affecting speech. people will find that they aren't able to speak effectively or articulate the words effectively. And they might experience, muscle tremor. And then they start to develop then it starts to progress as limbs become wasteful. In other words, the muscles become atrophied. And, there's just no nerve supply to the muscles. And so, but the important thing is that the sensory neurons are okay. Now, with the Bell's palsy, you'll find, or the bulbar palsy is actually, it's progressive because it affects the bulbar nuclei. These are the cell bodies in the brainstem. And they cause it's a cranial nerve process which causes weakening of facial muscles, causes swallowing issues, then it affects the pharynx and the epiglottis. And then the first sort of facial type symptoms people will experience is dysphagia, which is lack of swallowing. And then they develop dysarthria, which is inability to articulate words so that speech gets affected. And when it really hits the bad spot is when you see this nasal regurgitation. Now, you will find dysphagia in other conditions like strokes. You might even find it in Alzheimer's disease. So there's a general thread in the genetics in relation to some of these symptoms. But the cognition features, these guys know exactly what's happening. So there's no presenting, everything's preserved in the relation to their sensory and cognition features. So they're aware of things, And their eye muscles are also well preserved, as you would have seen with Stephen Hawking.
Yeah. What about things like central control of temperature versus peripheral control? Like, I would imagine if you can't move your legs, then you haven't got the veins pumping up blood from the periphery, so therefore you might get pooling of fluid in the ankles, like a dependent edema, which of course might affect temperature in the peripheries. Is there any central dysregulation of things like temperature? That would be more of a hypothalamic type thing, wouldn't it?
It probably would be, and this is not a typical presentation in MND. It's motor neurons that are affected. So what you will find more than fluid retention, or those are secondary events, because secondary events is associated with inability to address those primary defects. So you might find, rather than fluid retention, you might find pressure sores as a result of inability, or respiratory infections, rather than temperature control. There may be a thyroidal imbalance or adrenal imbalance later down the line, but the primary construct of MND is associated with that motor neuron dysfunction.
Although it's only 10%, I think it's a static, if you like, thing that researchers can focus on for causality and hopefully some treatment. That's the genetics. Can we delve into a little bit more of the genetics? What sort of genes were identified and how they sort of proposed to be an effect, if you like, of the condition?
Well, as I said, there seems to be a bit of a race going on as a result of further studies on genetics. We're using genetics to identify our ancestral lines, and now geneticists are on the bandwagon identifying specific gene mutations associated with MND. Some of them might be hereditary, others might be somatic or acquired, and you will find that the ones that are currently studied are genes like NEK1, and this is involved in motor neurons, helping keeping the shape of the motor neurons and keeping the transport systems open. Another gene that is studied quite extensively right here in Australia is C21ORF2 and also C9ORF72 gene. These genes are really abundant in nerve cells and neurons, and they're involved in the outer layers of the brain, like the cerebral cortex, and they involve your control movements, like your motor neurons. So we're finding that gene is also being identified. And one that we're quite familiar with is superoxide dismutase, SOD1.
Oh, yeah.
Yeah, that in 1993, that gene was identified, and we found that about 20% of familial Remember, only 10% of all MND is familial. So 20% of these genetically predisposed MND patients have had SOD gene mutations found. And they found in right now at the moment, they've also found that it accounts for about 65% of all MND. This is the latest study in terms of genetic or familial MND. Another gene that is all these genes tend to affect how proteins actually build up and these toxins migrate to the cells. Another one that is I guess being studied at the moment is TPD43 gene. It's another one that is being associated with MND, and your heat shock protein 27, HSP27. These are basically transactive protein responses, and they expressed really early in development before birth, and they involved in the nervous system and these organ development dysfunctions. So these are some of the genes that are now currently being talked about and studied and reported in the literature at the moment.
When we're talking about these genes, can you take us through what's happening with the pathophysiology at the cellular level? Like, are we seeing a damage, if you like, maybe parallel to Alzheimer's, like, the neurofibrillary tangles, the beta amyloid plaques? Are we seeing these genes cause a similar type of pathophysiological process?
The pathophysiology of MND is not being defined, but there are a few theories out there, and a lot of them are studied and quite extensively studied, and a lot of them are associated with the toxicity of your beta-methyl amino alanine. Whether it is derived from your ingestion of cycad seeds or whether it is as a result of exposure to blue-green algae, these neurotoxic elements, they are basically accumulate and they misincorporated it as a result of poorly functioning recycling and refolding machinery of the proteins. And so what they do is they don't fold correctly and they build up as like junk inside the cell over time, and that junk eventually chokes up that cell and it sends that cell into programmed death or suicide, And so our focus, therefore, and a lot of the study has been along the lines of two mechanisms. We have the only approved drug called Relutech or Riluzole, and there are two mechanisms by which it works. One is it is an NMDA inhibitor, and the other is that it is a glutamate antagonist. So the theories that are postulated as a result of seeing these high levels of BMAA can be associated with what is causing that underlying issue. So having researched a lot about amino acids, and as you probably well know, I love my amino acids.
Yes.
I've actually investigated the effect of where BMAA, why does it become neurotoxic? Now, we know that it actually occupies the serine receptors, allowing for glycine and serine to be depleted at in the bloodstream, but and the reason being is that they're occupying those receptors, so they're mimicking. BMAA is mimicking the effect of serine. So currently in various blogs, you can often see patients are taking serine. Now, as a result of researching a little bit about this, I use my amino acids at the rate of anywhere between 1 and 3 grams per day. But serine in this instance has been given up to 30 grams per day and have noticed some changes. Again, there's still a lot of study to be done in the area of amino acids, but it's really working along the lines of two major mechanisms that we know of. And obviously, there are many more mechanisms at hand which we still need to understand.
So just with regards to serine, if you're using 10 times the amount that would normally be used, is there potential for, I don't want to make a wild claim of cure, right? That's out of the bounds of reality, but an abrogation of symptoms so that you get a lesser decline?
There are there's so many various theories and postulations out there. Just getting an understanding of why these medicines are working and under which pathways they're working opens up the opportunity for integrative practitioners to understand the mechanism and then look at those constructs. Serine is an amino acid, which is your intermediary precursor to glycine, which is needed for manufacture of GABA. So we found that GABA agonists, such as gabapentin, have also been used, but have not shown any beneficial effect in MND patients. But serine is actually a very important amino acid. It's used in the folate pathway in methylation. But it's more importantly, it's used to manufacture nerve cell sheets. It's used in the production of immunoglobulins and antibodies. It's used in the synthesis of glycine, of choline, of your fatty acids and your sheets around these nerve fibers. And it's also involved in transamination from glutamate. So that glutamate toxicity is associated with serine. So there's a blockage in the nerve pathway somewhere along the line.
Yeah.
These proteins are not being folded effectively, and so your BMAA is becoming toxic as a result of a lack of the mechanisms of conversion and synthesis and manufacture and metabolism of serine, glycine, and there's a number of other amino acids as well.
You mentioned serine and you mentioned choline, which of course are components of two of the lecithins, phosphatidylserine, phosphatidylcholine, and you're talking about nerve sheaths. Phosphatidylserine's shown facility in helping to protect against certain damages. Do you ever use phosphatidylserine or PS, or do you use the amino acids and some of the substrates that might be used in helping to make the sheaths?
All right, so there's a number of opportunities here. You can use something like sphingolin as an example, which is a sphingolin molecule, which really is supporting myelin sheath production. But from an amino acid perspective, your cholines are absolutely essential. They are manufactured through the SAMI pathway in methylation. Yep. They are needed for your cell membrane, phospholipid membrane function. They also needed to maintain the fluidity and the surface tension of every cell. But most importantly, they are needed as neuromodulators. That is the ocean under which your neurotransmitters fire. If you don't have your choline derivatives, they are not neurotransmitters, they are modulators.
Right.
And if they are actually the ocean. If you have your neurotransmitters firing across a dry dock, you've got no neurotransmission induction pathways happening. And the reason is that you don't have those choline derivatives. Now, choline could be choline, inositol, some of the L-theanines. These are related, phosphatidylcholine, phosphatidylinositol. These are very, very important neuromodulators that would play an adjunctive role, perhaps not a primary role, but an adjunctive role.
Yeah.
And like herbs, amino acids do not work individually. They work synergistically with each other because one interconverts to the other. So typically I would actually identify amino acid status and then fit in the very amino acids. Some of the work has already been done by Deanna Protocol. It's a metabolic therapy predominantly aiming at providing the fuel in the citric acid cycle intermediates and specifically and I use this as well, is the AAKG, which is arginine alpha-ketoglutarate, together with alpha-ketoglutarate. That stimulates that 6-phenol-CoA pathway in the citric acid cycle, together with branch-chain amino acids. So that's leucine, isoleucine, valine, very important. Together with methionine, creatine. Creatine has been shown to be very, very effective in building up your muscle sheets. Choline and its derivatives, arginine, and there's a whole bunch of other amino acids. So I use a synergistic blend of these amino acids. And these amino acids are never working on their own. They're working with specific B group vitamins and magnesium to stimulate. Its cofactors are needed to stimulate its conversion, utilization, synthesis, and metabolism. So I find that the amino acid therapy is very, very useful, in line with other antioxidants.
I got to say, as soon as you said the use of the drugs as an MNDA inhibitor, I was thinking magnesium for anti-excitation action, and reducing the calcium flux inside the cell.
Absolutely.
Dose of magnesium? Do you ever have to go massive dose, like you're using massive doses of the amino acids, the serine?
Look, I have never used a high level of serine. I tend to use a synergistic blend of it, but having done the research lately, I would probably be increasing the level of serine in the amino acid blend for these particular MND type patients.
Yeah. Obviously, people have got to learn about these blends and indeed what to use. Have you developed anything to teach other people about this?
Look, amino acids have been an area that I'm really passionate about, and so yes, I've developed a masterclass on amino acids. Right from the boring stuff about each amino acid and the materia medica about, and more importantly, therapeutic value of these amino acids, how they interplay with each other in the gastrointestinal system or in specific disease states, neurological systems, etc. And the cherry on the cake is actually how to compound amino acids using an algorithm that I had used in my compounding pharmacy days many, many years ago, and is still used today by some of the compounders that I've passed the information on to. So, yes, so that's an amino acid masterclass.
Yep.
I've called it the alchemy of amino acids, in line with my book called Alchemy of the Mind.
Yeah.
And so Alchemy of the Mind, incidentally, is a book that I published last year about neural chemistries. And one of the chapters is really how neural chemistries, or the chemistries of neurotransmitters, affect every organ system,
yes.
whether it be the adrenals or the thyroid or the gut. There's a huge plethora of publicity about the gut-brain axis. So, it's connecting all these dots and how the brain affects libido, stress, and also the toxicants. We're so exposed to toxicants. So, and as we well know, that MND can play a role in or has a underlying causative factor of perhaps some level of toxicity.
Yeah. So I've got to ask, so that you can give the details for our listeners, where and when is this course being taught? Do you do it regularly, or have you only done it once or twice?
This course will be available online. So, so yes, definitely contact me at Vanita at vanitadahia.com. Or just look me up on the website and it will be available.
We'll put that up on the FX Medicine website for our listeners, definitely.
That will be lovely, yes,
yeah.
Thank you.
What about drug-nutrient interactions? You're dealing with, drugs that are trying their best to decrease damage to the motor neurons. You'd have to be acutely aware of interactions. Any major things to be mindful of here?
I think more rather than interactions is how do we manage this patient? What are the current drug therapies available, and then look at the patient's effects. For example, the swallowing reflex, the cramps, should we use baclofen, should we use various anti-infective agents? So there's a number of trials that are out there. Shall I tell you about some of the trials on some of the drugs that
Yes, please do.
Okay, so there are some trials, and obviously with every drug comes a materia medica. So you have a look at the MSDS file and definitely look at their side effects and investigate their interaction. But most importantly, it's quality of life for this MND patient. Obviously, these patients are immobile, and so these drugs are going to play a role. So they're going to have the gastric reflux, so you might need to use a PPI. But some of the major drugs that are currently being investigated right now and undergoing phase 1, phase 2 trials, some of them are called tamoxifen, which we know is used for breast cancer, telampanol. These are currently in phase 2 trials. Antibiotics, which we are using for severe bacterial infections like minocycline and ceftriaxone, are in phase 2 trials as well. Thalidomide, the horrible thalidomide, is also being trialed at the moment. Now, there's some interesting stuff going on. We are now trying the next frontier in the treatment of MND at the moment is paying the Carlo Rinaldi. He's published in Natural Reviews of Neurology, and he's talked about the next frontier in treatment of neurological disorders. And that is your ASOs, antisense oligonucleotides. Now, we use these nucleotides. They basically inhibit viral replication.
Yeah.
And the first generation is used predominantly for cytomegalovirus. But now they're finding that they can bind to non-coding RNAs and toxic RNAs. So there are 2 drugs currently on the market put out by Biogen under the name of Speranza. And that's called eteplirsen and nusinersen. These are 2 drugs that are currently out on the market, and they've just gained FDA approval. Another mechanism which we should be looking into is the issue of copper, ATSM.
Right.
In the late 2016, there was a collaboration of various professors at the University of Melbourne, Dr. Anthony White, Professor Paul Donnelly. They actually looked at this particular mechanism of copper, and they are virtually repurposing some of the HIV drugs, one of which is called Truimeq, Triumeq, and it's working along the copper pathways. So don't understand the mechanism yet, but it is involved in some of the studies. Another one that is possibly worth making mention of is some of the cytokinetics. They in phase 2 clinical studies. This has just been presented very recently in 2018 at the annual Cure SMA conference. Dr. John Day has been involved in the release or study of reldesemtiv. It's currently a subject of 3 phase 2 clinical trials at the moment.
Yeah.
This is a product released by Astellas Pharma. That's one that's been studied at the moment. Another one that's been studied is squamulene. It's an anti-cancer and antiviral drug. And they found that this particular drug affects the aggregation of alpha-synuclein. Now, the synuclein accumulates when iron accumulates in the production of L-DOPA. So when L-DOPA is not formed sufficiently, then iron starts to accumulate, and that increases the aggregation of L-synuclein. And this is where...
Is that like parallel to Parkinson's?
It's parallel to Parkinson's. A lot of their studies are now worked along the lines of Alzheimer's, Parkinson's, and these neurological diseases.
Wow.
So there's quite a few, studies. One in Japan has also been done by Mitsubishi Pharma on edaravone. That's another drug. And then, look, there are drugs that we're using right now, like lithium, valproic acid. We're using some of your similar neurotropic growth factors, phenylbutyrate, gabapentin, all with varying degrees of efficacy.
Yeah. And what about natural agents? Any research, or is there anything else that's useful apart from the amino acids?
Yes.
You mentioned the B vitamins, and I'm wondering about herbs. I'm wondering about if there might be anything that's useful.
So some of the natural items that are used currently and with great effect, the whole focus on natural ingredients is to support the motor neurons and preventing and provide the antioxidation, intracellular antioxidation, also supporting the glutathione production as well. So alpha-lipoic acid does that. Your B12 methylating cofactors, B12 and folate, they are involved in Bell's palsy. Coenzyme Q10 is a very powerful antioxidant. It's a major coupling agent within your electron transfer chain, and it helps with energy production. Magnesium, obviously. Magnesium is a very powerful NMDA. It helps lower your glutamate toxicity.
Yep.
Now, if we're looking at glutamate toxicity, there are other things such as theanine, taurine, green tea, Bakel's skullcap, curcumin, ashwagandha or withania, vitamin B6, magnesium, some of your smart brain foods such as vinpocetine. These are used on natural agents to assist with glutamate toxicity. And then the other mechanism we spoke about as well is your NMDA receptors. They are antagonized or inhibited by, as you said earlier on, magnesium, yes. But hormones like progesterone as well is an NMDA inhibitor. We use huperzine, taurine. Taurine activates your GABA receptor, so it's a great NMDA antagonist. Amantadine is a drug that is used for Parkinson's and Alzheimer's. That's another NMDA inhibitor. Amino acids like agmatine, which is a metabolite of arginine, is also an NMDA inhibitor. You can use drugs such as dextromethorphan, and that's used in your cough syrup.
Yeah.
Or phenadrine, which is basically a muscle relaxant, methadone, ketamine, memantines. These are your drugs, opioid drugs. There's been a couple of studies on the use of nitrous oxide as well, this laughing gas, as an NMDA inhibitor.
Wow.
But as far as herbs are concerned, one very important amino acid is N-acetylcysteine as well.
Yeah.
You mentioned herbs, so some of the herbs that are currently used, the focus in the case of herbs is really neuroprotection, anti-inflammatory. So some of the herbs that are used in neuroprotection are lion's mane, withania, which is an nervine adaptogen. But then there are other neuroprotective herbs as well, and I'm sorry I can't remember its generic name either, like bacopa, Bakel's skullcap, soda-cola. These are holy basil. These are really great other neuroprotective agents. There's one that is worth making mention of, and this is a Chinese study using intravenous crude astragalus root.
Wow.
So don't know enough about it, but I do know that it is used in MND as chi-invigorating herbs, and they've done a report of 31 cases, so that's quite interesting.
And quite large for MND, because it's not going to get a lot of, you're not going to be looking at huge cohorts of patients anyway, thankfully.
No, you can't look at very many because of the percentage of patients, but there is room for further study in the area of herbs. With MND patients, they have inflammation, so you've got to reduce that with herbs such as bucerium, turmeric, Bakel's skullcap, cat's claw. Cat's claw and Bakel's skullcap are probably the two major herbs that you would use.
Yeah.
Cordyceps and reishi as well, astragalus, hemidesmus, which is obviously an immunosuppressant. They also being used.
There's obviously so much to delve into here, and I think responsibly you'd have to look at this in a formalised setting, I think I must urge our listeners to undertake your training program with regards to compounding of amino acids and also other nutrients as well to combat something as serious and as devastating as motor neuron disease. Vanita, I can't thank you enough for taking us through this. You have obviously delved into this a massive amount, and thank you so much for taking us through your expertise today on FX Medicine.
Thank you so much.
This is FX Medicine. I'm Andrew Whitfield Cook. FX Medicine Live will be at Tammy Guest's Naturapreneur Experience from the 16th to the 17th of February 2019. For more information and to book your tickets, please go to tammyguest.com.